Good afternoon, everybody. So, my dear students, in the previous class, we discussed about the synopsis part of this electromagnetic induction chapter. So, in today's session, we will going to solve the question and answer session for this topic. So, in electromagnetic induction, most of the concept will going to become on the magnetic flux and the magnetic field. Before discussing about that, here there is a small table. So I request all the students to write down this table, which is going to be helpful in both the competitive exam and as well as the board exam also, especially in cracking the answer for multiple choice questions. So observe here the table is about the various positions of relative motion between the magnet and the coil. So here they are given the 5 columns. In that the first one, position of the magnet, and next direction of induced current, and the behavior of phase of the coil, type of magnetic force, it is whether it is going to be attractive or repulsive, and magnetic field linked with the coil and its progress as viewed from the left. So illela ನೀವು observe ಮಾಡಬಹುದು table ಅಲ್ಲಿ. So first I will going to give 1 minute time to all the students. Just note down this table, which is going to be very much helpful. Quickly. Okay. Other observe here. Here in all the diagrams, this is a magnet which is going to be moving in horizontal direction. ನೀವು ಕೂತರ ಪ್ರಕಾರ ನಮ್ಮ ಎಡಗಡೆಯಿಂದ ಬಲಗಡೆಗೆ magnet move ಆಗ್ತದೆ ಎಂದು ತೋರಿಸಿದ್ದಾರೆ. And in front of that, there is a coil such that the magnet is moving towards the plane of the coil. Okay. And here observe. The first one they are given. When the north pole of the magnet is going to be moving towards the coil itself, plane of the coil ಕಡೆಗೆ magnet move ಆದಾಗ observer ನೋಡ್ತಾ ಇರೋ ಹಾಗೆ ನಾವು ನೋಡ್ತಾ ಇರೋ ಹಾಗೆ, if the magnet is going to be moving, then the direction of the induced current is going to be in anti-clockwise direction, and the face of the coil is going to be act as north pole again, as a north pole. So this is also north pole. This face of the coil is also going to be act as north pole. So both are going to be repulsive in nature. As a result, the magnetic field is going to get indicated by cross mark, as I told in the previous class. And what about the value of the magnetic field linked with the coil? The coil, the total magnetic field value goes on increases. At the same time, suppose if the magnet is going to be moved away. So again, using Lenz's law and all those, the effects will be always opposite to that of the previous column. So ಇಲ್ಲಿ anti-clockwise ಇದ್ದು ಇಲ್ಲಿ clockwise ಆಗುತ್ತೆ. ಇಲ್ಲಿ act as north pole ಇದ್ದು here it is going to be act as south pole, and here it is repulsive force ಇದ್ದು attractive force ಬರುತ್ತೆ, and the direction of the magnetic field is going to be, it is represented by cross mark, and the value is going to be get decreases. Why it is going to be decreases? Because the magnetic flux value is going to get decreases. So instead of that, suppose the magnet itself is going to get turned by 180 degree. However, south pole, the movement of south pole towards and away from the coil. So third column observe ಮಾಡಿ, south pole of the magnet is moving towards the coil, then the face of the coil should going to be act as south pole according to Lenz's law, because it should going to be opposed the motion of the magnet itself. So the direction of the current is going to be as yes. As I told in the previous class, it should be in clockwise direction as observed by the observer, and it's going to be act as south pole. So both are going to be S and S. They should going to be, they are alike pole. As a result, they are going to be repulsive, and that is going to be represented by dot mark, and the value of the magnetic field strength is going to be get increases. So ಅದೇ ತರ the reverse one, when we are going to take the south pole away from the coil, then the direction of the current is going to become anti-clockwise, and the face of the coil act as north pole, and force is going to become attractive, and it is going to be represented by dot mark, and total magnetic flux value going to be get decreases. So this is going to be helpful. So next, let us consider we're going to be come across to the question and answer session. So yeah, first I'm going to come across the first one. So yeah, then given current in a coil is changes from 4 ampere to 0 ampere. So for the first one, so observe current is going to be changes I value changes from 4 ampere to 0 ampere. So DI value change in the current value is 4 to 0. 4 minus 0 that is equal to 4 ampere in 0.1 second. So time interval is very small, that is 0.1 second. And the EMF induced is 100 volt. So E value is going to be 100 volt. Then the self-inductance of the coil is L value you have to find. So here we know the equation as E is equals to minus L into DI divided by dt. In solving the numericals, we have to take only the magnitude, that is modulus value. So here we are going to calculate this minus symbol or modulus of this value. Then the equation is L into DI divided by dt. So substitute the values. Here the self-inductance of the coil L value we want LHSL E ಇದೆ, RHSL L into DI by dt. So L is equals to ಮಾಡಿದಾಗ E into E DI by dt ಕಡೆ ಕಳಿಸಿದಾಗ it is going to become dt divided by di. So this will be equals to E value that given is 100 into dt value is 0.1 divided by di value is 4. So it is going to become 100 into 0.1. What is going to get 10 birthday? 10 divided by 4. So 10 divided by 4 means 4 ones are 4 twos are. So 0.5 remains. So that is 4.2.5. So 2.5 we found the value of self-inductance. Its unit is Henry. So 2.5 is the answer. So in that 2.5 is the correct answer for the first question. So the next one is we're going to be come across the second one. So in that second one, observe that given two similar circular loops carries equal currents in the same direction. So two circular loops, they are going to be carries the current in the equal current in the same direction. So ಎರಡು ಕೂಡ ನೀವು anti-clockwise ಅಂತ ಅಂದ್ರೆ ಎರಡು ಕೂಡ anti-clockwise ಅಲ್ಲೇ same amount of current. ಇದು ಕೂಡ I ಇದೆ, ಇಲ್ಲಿ ಕೂಡ I ಇದೆ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. On moving the coils further apart, so let us consider they are already at a distance of AB. ಈಗ ಮೊದಲು ಇರತಕ್ಕಂತ ಡಿಸ್ಟೆನ್ಸ್ D ಡಿಸ್ಟೆನ್ಸ್ ಅಂತ ಹೇಳಿ. On moving the coils further apart, so ಇದನ್ನ ಇನ್ನೂ ಸ್ವಲ್ಪ ಮೂವ್ ಮಾಡಿದ್ರೆ, ಇದನ್ನು ಕೂಡ ಇನ್ನೂ ಸ್ವಲ್ಪ ಮೂವ್ ಮಾಡಿದ್ರೆ, ಆವಾಗ distance is going to become D dash. The separation is going to get increases. Then, on moving the coil apart, the electric current will remains unaltered, ಅಂದ್ರೆ ಏನು ಚೇಂಜ್ ಆಗಲ್ಲ ಅಂತ, increases in one and decreases in the second. ಅಂದ್ರೆ ಒಂದರಲ್ಲಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಇನ್ನೊಂದರಲ್ಲಿ ಕಡಿಮೆ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ increases in both, decreases in both. ಇವಾಗ ಒಂದನ್ನು ಮಾತ್ರ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಅದು let us consider coil B is going to be taken away. So when the coil B is taken away, magnetic field produced by B with respect to A is going to get changes. So that is going to be induces an EMF. When an EMF is going to get induced, then automatically current through the coil A is going to get increased. It will increase. ಅದೇ ತರ B ಅನ್ನ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇಟ್ಟು A ಅನ್ನ ನಾವು ಮೂವ್ ಮಾಡೋದಕ್ಕೆ ಒಂದ್ ವೇಳೆ ಹೋದ್ರೆ, then that in that case also it is going to be there is a change in the magnetic field value produced by coil A. So it is going to be induces an EMF in coil B. In that case, again, current is going to get increases. Hence, the current is going to be increasing in both the coils, which are going to be opposing the movement of both the coils with each other. As a result, the answer is here increases in both. This is according to Lenz's law. Observe. Near a circular loop of conducting wire, as shown in the figure, an electron moves along a straight line. The direction of induced current, if any, in the loop is. So, the values are indicated near a circular loop. Circular loop of conducting wire. Of course, if it is going to be conducted, as shown in the figure, an electron moves. Electron move direction. So, it is going to be from left to right as with my frame of reference. So I'm going to rewrite that diagram. So observe, this is a circular coil. If a electron is going to be moving, so here electron is moving in the diagram put together. I will going to make the arrangement such that I will going to give the name for that conductor as AC and the midpoint I will take it as B. Okay, electron. When the electron move from A to B, when the electron move from A to B, direction of the current is from B to A. So direction of current is equal. So as totally the electron is going to be moving from A to C. So the direction of the current is towards opposite to that of the flow of the electrons. And that is I value is going to be varies and type. I varies. So next one, what about the magnetic field? Here it is going to become say a conductor which is going to be carries a current in the towards the horizontal direction. So if you are going to be apply the right hand thumb rule, ivaga nam prakara magnetic direction of current is equal ಇದೆ ನಮ್ಮ ಎಡಗಡೆಗೆ. If you are going to be apply the right hand thumb rule, there exists a magnetic field. But what about the magnetic field value? Magnetic field value, it is going to be varies from one end to while another end. ಏನಾಗುತ್ತೆ, ಒಂದ್ ವೇಳೆ ನಾವು ಎ ಇಂದ ಬಿ ಹೋಗ್ತಾ ಹೋದಾಗ ಆವಾಗ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದಿಸ್ ಕಂಡಕ್ಟರ್ ಅಂಡ್ ದಿಸ್ movement of the electron, it is going to get varies. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಫಸ್ಟ್ d value is going to be goes on and decreases. D value goes on first increases. First the D value is going to get increases first. Then while moving from B to C, again the value is going to get increases. Once it is going to get decreases and another times it is going to get increases. So when the distance is going to get vary, automatically magnetic flux value or area value is going to get changes. Hence the current value is going to get changes. And in this case, the direction of the current is going to be always in anti-clockwise direction. The reason is, it is here the magnetic field is going to be act as towards the board itself. So as I told in the previous class, it is represented by the cross mark. So in this cross mark, when the direction of the magnetic field is in this way, the direction of the induced current is going to be always in anti-clockwise direction. So the direction of the current is in anti-clockwise direction. Next, there is a fourth one. There is a uniform magnetic field directed perpendicular and into the plane of the paper. So here they are going to indicated the direction of the magnetic field is going to be indicated as there is a uniform magnetic field directing perpendicular and into the paper, which is going to be represented by the cross mark, and into the plane of the paper, that is away from the observer. An irregular shaped conductor loop is slowly changing into a circular loop. So if you are going to take an irregular shaped conductor, which is going to be get turned into regular shaped, that is into a circular loop. Either irregular regular circular loop I convert ಆಗುತ್ತೆ. Loop in the plane of the paper, then current is induced in the loop in the anti-clockwise direction. Current is induced in the loop in the clockwise direction. AC is induced in the loop. No current is induced. So as the magnetic field is going to be directed towards the plane of the board. So as I told in the previous one, that is the first slide I given. When you want to observe that table, so in that table, they are going to be given such that when the direction of the field is going to be represented by crossword, then the direction of the current is going to be always in anti-clockwise direction. So the current is induced in the loop in the anti-clockwise direction. So now let us move on to the next one. So the fifth question that given, the energy stored in an inductor of self-inductance L Henry carrying a current of I ampere is. So direct equation, we know that the equation for the energy stored by a inductor is going to be given by U. U is equal to of Li square. So of Li square, that is of Li square. Second option is the correct answer for the question number 5th. So let us move to the next question. So that is the 6th question. Next one is direction of motion, direction of current induced in a wire moving in a magnetic field is found using Fleming left-hand rule, Fleming right-hand rule, Ampere's rule, and as well as right-hand clasp rule. So, direction of current induced in a wire, suppose if we're going to take an EMF is going to get induces. Okay, if it is going to be carries a current, then direction of current induced in a wire moving in a magnetic field. Suppose it is going to be moving in a magnetic field, then it is going to be very clear as the conductor is going to be moving, that is due to its motion, and EMF that is going to be induces, which is called as motional EMF. So that motional EMF, which is so EMF is going to get induced due to its movement, that is due to the amount of force F value exists agate F, and in a magnetic field B, and with respect to direction of I. See, the direction of motion or force acting on the conductor represented another parameter is magnetic field, and if it is going to be carries a current, that is induced current. All those three are going to get represented by Fleming right-hand rule. According to Fleming right-hand rule, suppose if you go to stretch the first three fingers of your right hand, such that this thumb is going to represent the direction of motion or force, and this forefinger is going to be indicating the direction of the magnetic field, and the middle finger is going to indicate the direction of the current. Hence, the correct answer for the 6th question is Fleming's right-hand rule. And the next one is the 7th question. We want to move. They are given two identical circular coils A and B are kept on a horizontal tube side by side. So again, they are going to given the previous type, but there is a little bit change. Two identical circular coils, both are going to be having the same size. That means same radius. A and B, one that is going to be given the name as A, another is going to be named as B, are kept in a horizontal tube. So here there is a tube. There is a tube by side without touching with each other. There is no contact between the two circular coils. If the current in the coil A increases, so current in coil A is going to get increased. In response, the coil B is attracted by A, remains stationary, is repelled or rotates. So remains stationary, which is highly impossible, because they are going to given, both are going to be the identified coils. So when the current in this A is going to get increased, according to Lenz's law, it is going to be try to induce an EMF towards the coil B. We are from the EMF induce try which is going to get opposed. Oppose coil A behavior coil B oppose that opposite thing, but it is repelled. So then current just slow again. Actually, ಕಾಯಿಲ್ ಬಿ ದೂರ ಸರಿತಾ ಹೋಗುದು. ಹಾಗಾಗಿ ದ ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಈಸ್ that is according to Lenz's explanation. So in that response, the coil B is going to be get repelled. So for question number 7, 3 is the correct option. Next, come across to the next question, that is 8th question. We are going to given about the solenoid. A solenoid of self-inductance. So in the 8th question, a solenoid of the self-inductance L value given is 2 Henry, carries a current of 1 ampere. I value is going to be of 1 ampere. What is the magnetic energy stored in the solenoid? So what is the magnetic energy stored? U equals to how much they are going to be asking. So here again, as we discussed in the previous question, Indian question month. So equation for the energy is U equals to of Li square. Nearby the question no. So 1 by 2. L value that given is 2 into I square, that is 1 square. So 2 gets cancelled. We remain with 1 square. 1 square value is 1. The unit of energy is joule. So 1 joule is the amount of energy. Hence, 4th one is the correct answer for 8th question. So come to about the next one. It is an aircraft with a wingspan of 40 meter length. So when we're going to take an aeroplane, it is going to be having the wings. So here they are given that wingspan, its length means from outer edge to outer edge. Then a wingspan, right? That length they are going to given is 40 meter, flies with a speed of 1080 km per hour in the eastward direction at a constant altitude. Altitude means height. So in the northern hemisphere, where the vertical component of the Earth's magnetic field is 1.75 10 to the power minus 5 Tesla, then the EMF developed between the tips of the wings is. So here also the condition of motional EMF. Aeroplane now on the conductor which is moving at a height on the above Earth surface. So Earth is going to behave as the magnet. So as a result, when the plane is going to be moving, so automatically there exists a certain magnetic field lines, means the plane is going to be moving in a changing magnetic flux value. Due to that, an EMF is going to get induced, that is motional EMF. So here, when we take that motional EMF, the equation for motional EMF we know that is E is equal to BV into L. But here, what are the values that are given to given? The value of the magnetic field is going to be given for 9th one. Yeah, for 9th question. Magnetic field is how much? 1.75 into 10 to the power minus 5 into velocity. Observe the velocity. They are given 1080 km per hour. So, you first it is not in SI unit. So when it is not in SI unit, we have to convert into SI unit. So kilometer per hour to meter per second, we have to make it a multiply by 5 by 18. Next, the length is going to be L value is that going to be given is 40. So 40. So the answer calculation, observe 1.75. I'm going to keep it this as it is. And 10 to the power minus 5 also as it is. Here. It will going to calculate, then 18 ones are 18 6 are going to becomes. So then we remain with 60 into 5 into 40. 18 ones are 18 6 is 108. So ಇಲ್ಲಿ 0 ಕೊಡುತ್ತೆ. 6 into 6 and 60 into 5 into 40 10 to the power minus 75. We're going to write this 1.75 as it is. So 60 into 5 into 40. 6 5s are 30, 34s are 12. So 12 6 into 5 into 4. It is going to become 120. So 2 zeros. So two zeros into 10 to the power minus 5. So quick calculation skills. 6 into 5 into 4. This is going to become 120. Here these two zeros, if we going to add, then it's going to become 12,000 into 10 to the power minus 75. So this is again equals to 1.75. This can be written as 12 into 10 to the power 3. 12 into 1000. So then we can write the 1000 as 10 to the power 3 into 10 to the power minus 5. So then the answer is going to become 1.75 into 12 into 10 to the power minus 2 will remain 3 and minus 5. So if you're going to multiply, then 12 and 8, it is going to become nearly 20. 1.75 into 12 is nearly 20. 20 into 10 to the power minus 2. Answer? No. Here, again multiply. 20 into 10 to the power minus 2, it's going to become 0.2. So EMF we are going to calculating 0.2 volt. So here the option that given is 0.21. So you can select option 4 is the correct answer for 9th question. So next. The 10th one, two coils have mutual inductance 0.005 Henry. The current changes in the first coil according to the equation I equals to Im sin omega t. ಸ್ವಲ್ಪ ಆಪ್ಷನ್ಸ್ ಅಂದ್ರೆ ಸಿಂಬಲ್ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ಕೊಂತ ಬೇರೆ ತರ ಯೂಸ್ ಮಾಡಿದ್ದಾರೆ. ಯೂಶುವಲಿ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ಆಸ್ I equals to I0 sin omega t ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ I equals to Im sin omega t. Im ಅಂದ್ರೆ ಪೀಕ್ ವ್ಯಾಲ್ಯೂ ಅಂತ ನಾವು ಹೇಳ್ತೀವಿ. ಇಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕರೆಂಟ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ವೇರ್ Im ವ್ಯಾಲ್ಯೂ that given is 10 ampere and omega value is 100 pi radian per second. The maximum value of the EMF induced in the second coil is. So mutual inductance, yeah, we know the equation for. So for the 10th one, E is equals to M into di by dt. And here that one, I is equals to Im into sin omega t. The maximum value, so Im value we have to calculate. So M value that given and Im value that given, induced EMF value, E value we have to calculate. So if you have the equation E is equals to, directly I am going to substitute M value. So of mutual inductance is 0.005. So 005 into di by dt. So ಇದನ್ನ differentiate ಮಾಡಿದಾಗ then we would get differentiation of I is Im into sin omega t. So this will be equal to 0. So this will be equal to 0.005 into differentiation of this is going to be given by Im into sin omega t. Differentiation is cos omega t into omega. Cos omega t into omega. So the maximum value, for maximum value, this cos omega t value should be equals to 1. So hagagi 0.005 into Im value that given is 10 into omega value that given as 100 pi. We're going to substitute. It's going to become 0.005. 100 into 10. It's going to become 1000 times 5. And this can be written as 5 into 10 to the power minus 3. 0.005 na 5 10 to the power minus 3 ಅಂತ ಬರಿಬಹುದು. Into 1000 ಅನ್ನು ಕೂಡ 10 to the power plus 3 ಅಂತ ಬರಿಬಹುದು. Into 5. So 10 to the power minus 3 plus 3 gets cancelled. We're remaining with 5. So 5. So for the first, that is 10th one, answer is EMF induced is 5. So the next one is about a long solenoid with 40 turns per centimeter. So the 11th one, N value is 40 turns per centimeter. So per centimeter, if we're going to convert into SI unit per meter, then it's going to be 40 divided by 100, because 1 meter is equals to 100 centimeter. So 40 per centimeter. So observe that observe a long solenoid with 40 tons. So that 11th question, N value is going to be 40 per centimeter. Then you meter convert is going to becomes 40. So centimeter to meter conversion ಗೆ 10 to the power minus 2 per the denominator ಆಗುತ್ತೆ. ಮೇಲ್ಗಡೆ ತಗೊಂಡಾಗ 100 ಆಗುತ್ತೆ. 40 into 100, it is going to becomes 4000. N value is going to be 4000 turns per meter ಆಯ್ತು. Carries a current of 1 ampere. So I value is going to be 1 ampere. The magnetic energy stored per unit volume U divided by V is how much? In joule per meter cube. So in the discussion we know that energy stored by a solenoid, which is going to be given by half B of B square divided by mu naught. ಇದು equation ಇರ್ತದೆ. So energy per unit volume actually into V ಬರುತ್ತೆ ವ್ಯಾಲ್ಯೂಮ್. ಆ ವ್ಯಾಲ್ಯೂಮ್ ಟರ್ಮ್ ನ LHS ಕಳಿಸಿದಾಗ U by V ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಕ್ವಶನ್ ಕೇಳಿರೋದೆ ಎನರ್ಜಿ ಸ್ಟೋರ್ಡ್ ಪರ್ ಯೂನಿಟ್ ವ್ಯಾಲ್ಯೂಮ್ ಅಂತ ಕೇಳಿದಾನೆ. ಪರ್ ಯೂನಿಟ್ ವ್ಯಾಲ್ಯೂಮ್ ಅಂತ ಡಿವೈಡ್ ಬೈ. So this will be equals to 1 by 2. So the magnetic field produced by a solenoid. Magnetic field produced by the solenoid is going to be given by the equation at the center. It is mu naught Ni. So mu naught Ni. So here the square is there. Square divided by mu naught. Divided by mu naught. So the answer is 1 by 2. So numerator na. So it is going to become so mu naught square N square I square divided by mu naught. So simplify ಮಾಡಿದಾಗ single mu naught gets cancelled. Then we remain with in the numerator mu naught N square I square divided by 2 ಉಳಿಯುತ್ತೆ. So this is the actual equation for energy per unit volume. So then mu naught value if we going to substitute, then we know that mu naught value is 4 pi 10 to the power minus 7 into N square. N value is 4000. So 4000 square into I value is going to be 1. Its square is also 1. So divided by 2. So it is going to becomes equal to 4 pi into 10 to the power minus 7, keep it as it is. This 4000 can be written as 4 into 1000. So that is 4 into 10 to the power 3 whole square divided by 2. So this will be equals to 2 ones are 2 twos are. We are remaining with 2 pi into 10 to the power minus 7 into 4 into 10 to the power 3 square ಮಾಡಿದಾಗ 4 square is 16 into 10 to the power 3 square is 10 to the power 6. Then we are remaining as the amount of energy per unit volume is equals to 2 pi into 2 into 16, that is going to becomes 32 pi into 10 to the power minus 7 and plus 6. ಇಲ್ಲಿ minus 7 ಇದೆ, ಇಲ್ಲಿ plus 6 ಇದೆ. So total is going to becomes 32 pi into 10 to the power minus 1. So this will be equals to 10 to the power minus 1 ಇಂದ ಇದು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ 32 ಇದ್ದು 3.2 ಆಗುತ್ತೆ. So 3.2 unit of this one is joule per meter cube. So 3.2 pi is the correct answer. So 3.2 pi. So for 11th question, option 1 is the correct answer. It is 3.2 pi. So next, a wheel with n spokes each of length capital M L meter is rotated with a uniform angular velocity omega in a plane normal to the magnetic field. The EMF induced between the axle and the rim of the wheel. It is example just your cycle wheel which is going to be rotates. Where it is going to be rotate? In the region of a magnetic field. So that given that wheel consists of n spokes. So ಇರ್ತಕ್ಕಂಥ ಕಡ್ಡಿಗಳು ಸಂಖ್ಯೆ ಕೊಟ್ಟಿದ್ದಾನೆ. ಎಷ್ಟು ಸಂಖ್ಯೆ ಇದೆ ಅಂದ್ರೆ ಕ್ಯಾಪಿಟಲ್ ಎನ್ ನಂಬರ್. ಈಚ್ ಆಫ್ ಲೆಂತ್ ಎಲ್ ಮೀಟರ್. ಪ್ರತಿಯೊಂದರದ್ದು ಕೂಡ ಉದ್ದ ಎಷ್ಟಿದೆ ಕೊಟ್ಟಿದ್ದಾನೆ ಎಲ್ ಮೀಟರ್. ಸೊ ರೋಟೇಟ್ಸ್ ವಿತ್ ಯೂನಿಫಾರ್ಮ್ ಆಂಗುಲರ್ ವೆಲಾಸಿಟಿ. ಅದು ಒಂದೇ ಸಮನೆ ತಿರುಗ್ತಾ ಇದೆ. ಅಂದ್ರೆ ಸ್ಪೀಡು ಜಾಸ್ತಿನೇ ಆಗ್ತಿಲ್ಲ, ಕಡಿಮೆನೂ ಆಗ್ತಾ ಇಲ್ಲ ಅಂತ. ಸೊ then I am going to asking the EMF induced between the axle and the rim of the wheel is. So EMF ಎಷ್ಟು induced ಆಗಿದೆ. So this is also the example for the motional EMF. Consider that wheel itself is a conductor which is going to be under rotation motion of a whatever may be the type of motion, but it is going to be present in a magnetic field. Due to that, so an EMF is going to get induced. That EMF, how we have to calculate? Let us calculate first the EMF for one spoke. Let it as delta E. For one spoke, the EMF induced. ಅಂದ್ರೆ ಒಂದು ಕಡ್ಡಿಯಲ್ಲಿ EMF ಎಷ್ಟು induce ಆಗುತ್ತೆ? I will going to take it as delta E. And for all the wheels, if you are going to take, then the net EMF is equals to E. That is going to be given by integration of delta E. Here little bit the calculus is also going to be get required as you studied in the mathematics. So the from where to where? So when it's going to be get started, the length is going to be 0. Then completely covers. Then the length is going to become L. So the EMF get induced depends on the length of the spoke. So the spoke ತಿರುಗ್ತಾ ಹೋದಾಗೆ ಅದರ length variation ಆಗ್ತಾ ಹೋಗುತ್ತೆ. First minimum ಬರುತ್ತೆ, next maximum ಬರುತ್ತೆ. Minimum 0 ಅಂದ್ರೆ before entering the magnetic field. After entering the magnetic field to completely, it's going to become the completely the length of the spokes. So if you're going to substitute, then the equation for EMF, that is motional EMF, from integrating from 0 to L, that is going to be given by BVL. So I'm going to write it as BV into L into the value is going to be, I'm going to take it as DL or BVL as we know the equation. So this will be equals to integration from 0 to L B into V can be written as R into omega as you studied in the first PUC. That is in rotation motion chapter. Linear velocity and angular velocity are going to get interrelated with V equals to R into omega into L into DL. So this will be equals to again integration from 0 to L into B. This R stands for radius. Radius is nothing but L. That is the length of the spokes into omega into L into DL. So you can take a small L itself. So this is going to becomes integration from 0 to L B into omega into L into L. It's going to becomes L square into DL. Now you have to integrate among that B omega are going to be constant. So I'm going to take it outside. B omega I'm going to take it outside. Integration of 0 to capital L, L square into DL. So this will be equals to B omega into integration of x square into dx. Integration of x square into d again. That is 1 minute. Wait. It becomes course. So the equation is BVL into DL. So V is R into omega. That L we taken it as a small element. So it as DL. Then the equation is going to become B into L into omega into DL. So this will be equals to integrating limit from 0 to L, integrating from 0 to L. B omega L into DL. So I'm going to take the constant values. Constant values are B and omega. Then we're remaining with integration of L into L under the limits from 0 to L. So this is equal to B into omega. Integration of L is going to becomes L square divided by 2 under the limits from 0 to capital L. So as the upper limit is going to be capital L, then the equation can be written as B omega square, small L jagadali capital L. So square divided by 2 is there 2. So the actual answer is B omega square L square divided by 2 is the total EMF induced between the axle and as well as the rim of the wheel. So as it is going to be consist of n number. So the answer is B omega square L square divided by T. N B omega. No, not omega square, just omega. B here, not omega, here just omega is there. Omega, not square, omega. E equals to B into omega into L square divided by 2. So the answer is B omega L square divided by 2. So B omega L square divided by 2. That is off. So that's one for 12th one. Option is 2. Correct answer. And the next one is 13th question. Here in the 13th question, they are going to given a bar magnet is allowed to fall vertically through a copper coil. So, ಇಲ್ಲಿ ಒಂದು copper coil ಇದೆ. So, here a bar magnet is going to be allowed to fall as they indicated. North pole is directing towards the earth. In a horizontal plane, the coil ಈ ತರ ಇದೆ. The magnet falls with a net acceleration. Now, let us consider the acceleration of this magnet as equivalent to acceleration due to gravity because it is going to be a freely falling object. Now, the net acceleration. So the movement of this magnet is going to get opposed by the coil. So coil oppose ಮಾಡುತ್ತೆ ಹಾಗಾಗಿ the value of the acceleration due to gravity is going to get decreased by the that of the coil. So as a result, G value here is going to become G dash. G dash ಆಗಲ್ಲ such that G dash is always less than G. ಹಾಗಾಗಿ the answer is less than G. That is for 13th question. The correct option is 3. So the next one, again they are given about the aeroplane. A jet plane wingspan of 20 meters is traveling towards west at a speed of 400 meters per second if the Earth's total magnetic field is 4 × 10⁻⁴ Tesla and the dip angle is 30 degrees. At that place, the voltage difference developed across the ends of the wing. There, as we discussed in the previous, that is the motional EMF, which is going to be given by E is equal to BV into L. But here the question that given is they are given about the total magnetic field value. So before that, observe, we know about the resolution of the vector. Suppose here in the case of resolution of the vector, here we are going to take this is going to be a vector P, this is going to be the vector Q, then this is going to be the vector R. So this is the resultant between these two. The same is going to be taken. Suppose if D is the total magnetic field produced by the Earth, and this is going to be its horizontal component, that is BH, and it is going to be making an angle theta. Then this is going to be its vertical component, that is BV. So here the question ಅಲ್ಲಿ ಕೊಟ್ಟಿರತಕ್ಕಂಥದ್ದು that given the value of L value ಕೊಟ್ಟಿದ್ದಾನೆ. L value is 20 meter. Okay. And traveling with a speed, velocity value is given directly in the SI unit, that is 400 meter per second. And next, total magnetic field. Observe here the value of the dip is represented by this angle that going to given is 30 degree. So the actual value we have to take is BV value. So E is equals to BV into V into L. So ಇವಾಗ ನಾವು ಇದನ್ನ ನಮಗೆ ಫಸ್ಟ್ ಪಿ ಸಿ ಗೊತ್ತಿದೆ. If this is R, then this is Q, then the equation is going to become this is going to become so P into sin theta into V into L. ಯಾಕಂದ್ರೆ ಅದು ವರ್ಟಿಕಲ್ ಕಾಂಪೊನೆಂಟ್ ತಗೊಳ್ತಾ ಇದೀವಿ. ಸೊ B value that given is 4 into 10 to the power minus 4 into 10 to the power minus 4 into sin theta. Theta value is 30 degrees, so sin 30 degrees 1 by 2 into V. V value is going to be 400 meter, that is 400 into L. L value is going to be 20. So if you go to substitute, 2 ones are 2 tens are, then we are remaining with 4 into 10 to the power minus 4 into 400 into 1000. It is going to become 4000. So this is going to be 4 into 4, 16 into 1000 10 to the power minus 4 into 4 into 1000 ಅಂದ್ರೆ 10 to the power 3 ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಇಲ್ಲಿಗೆ 16 into 10 to the power minus 1. So 16 into 10 to the power minus 1 is but EMF E is equal to ಇದು multiply ಮಾಡಿದಾಗ ನಿಮಗೆ 1.6 volt ಸಿಗ್ತಾ ಹೋಗುತ್ತೆ. So the correct answer for the 14th question is option 3rd. Next, a jet plane having a wingspan of 25 meters is traveling horizontally towards east with a speed of 3600 km per hour. If the Earth's magnetic field at the location is 4 into the power minus 4 Tesla and the angle of dip is 30 degrees, then the potential difference between the ends of the wing is. The question is the same type here, but the difference is the velocity value is going to be given in kilometer per hour. Just convert into meter per second. That is 3600 into 5 by 18 ಮಾಡ್ಕೊಂಡ್ರೆ ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ B value ನೇರವಾಗಿ ತಗೊಳ್ಳಂಗಿಲ್ಲ ನೀವು. B is equal to BB sin theta. So theta value that given is 30 degree. Then if you are going to substitute, then the correct answer you will going to given the answer you will going to get it as 5 volt. Answer 5 volt. Next, I will going to move on to the next question, 16th question. The magnetic flux linked with a coil varies as phi is equals to 3t square plus 4t plus 9. So observe here the magnitude of EMF induced E is equals to d phi by dt. I will take only magnitude. So this is equals to d phi differentiation of phi. Phi value that given is 3t square plus 4 plus 9. So if you go to differentiate with respect to time, the equation is going to become, so 3t square is going to become 60 plus 4t actually. The 4t is going to become just 4. So the differentiation of 9 is going to be 0. In 2 seconds, so EMF induced, that is 6 into t value is 2. 6 into 2 plus 4. 6 into 2, 12 plus 4, it is total 16 volt. 16 volt is the correct answer. They are going to given option 2. So for 16th question, correct answer is option 2. So observe, consider the situation given in figure. The wire AB another one wire is sliding ಜಾರ್ತಾ ಇದೆ on the fixed trails. So just like a railway tracks, these two lines with a constant velocity, it's going to be moving with a constant speed. If the wire AB is replaced by a semicircular wire, AB that going to given, it is a straight wire now. ಈ ಕೊಟ್ಟಿರತಕ್ಕಂಥ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ AB ಅನ್ನೋದು ಏನು ಕೊಟ್ಟಿದ್ದಾನೆ, ಒಂದು ಸ್ಟ್ರೇಟ್ ವೈರ್. And if it is going to be, if the AB is replaced by a semicircular ಅಂದ್ರೆ ಅರ್ಧ ಸರ್ಕಲ್ ಇರ್ತಕ್ಕಂಥ ಒಂದು ವೈರ್ ಆಗಿ ನಾವು ಅದನ್ನ ಕನ್ವರ್ಟ್ ಮಾಡಿ ಹಾಗೆ ಮತ್ತೆ ಮೂವ್ಮೆಂಟ್ ಮಾಡಿದಾಗ the magnitude of the induced current is I value is going to get changes. So we know the equation as I is equals to E divided by R using Ohm's law, and EMF is due to motional EMF. E is equals to BV into L. So just we are going to be changing the shape change ಆಗ್ತಾ ಇರೋದ್ರಿಂದ resistance value ಏನು change ಆಗೋದಿಲ್ಲ. ನೆಕ್ಸ್ಟ್ ನಮ್ಗೆ ಏನಾದ್ರು ವೇರಿಯೇಷನ್ ಅಂದ್ರೆ EMF ಬಗ್ಗೆ. EMF ಮೋಷನಲ್ EMF E = BV × L. ಸೊ ಬಿ ವ್ಯಾಲ್ಯೂ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ಚೇಂಜ್ ಮಾಡ್ತಲ್ಲ, ಬಿ ವ್ಯಾಲ್ಯೂ ಅಂದ್ರೆ ಸ್ಪೀಡ್ ಕೂಡ ಚೇಂಜ್ ಮಾಡ್ತಲ್ಲ, ಎಲ್ ವ್ಯಾಲ್ಯೂ ಅದ್ರದ್ದು ಲೆಂತ್ ಕೂಡ ನಾವೇನು ಚೇಂಜ್ ಮಾಡಿದ್ರೆ ಅದು ಎಷ್ಟಿದೆ ಅಷ್ಟೇ ಇದೆ. ಜಸ್ಟ್ ವಿ ಚೇಂಜ್ ದ ಶೇಪ್ ಮಾತ್ರ ಚೇಂಜ್ ಮಾಡಿದ್ದೇವೆ. ಹಂಗಾಗಿ ಇಲ್ಲಿ ಐನು ಕಾನ್ಸ್ಟೆಂಟ್, ಆರ್ ಕೂಡ ಕಾನ್ಸ್ಟೆಂಟ್, ಅದು ಕೂಡ ಚೇಂಜ್ ಆಗ್ತಾ ಇಲ್ಲ. ದೆನ್ ಐ ಶುಡ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ರಿಮೇನ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಸೊ ದ ಆನ್ಸರ್ ಈಸ್ ರಿಮೇನ್ಸ್ ಸೇಮ್. It doesn't change this. It is irrespective of the shape of the conductor. Next, a rod of length 2 meters slides with a speed of 5 meters per second on a rectangular conducting frame. As shown in the figure, there exists a uniform magnetic field of 0.04 Tesla perpendicular to the plane of the figure. If the resistance of the rod is 3 ohm and current through the rod is, so this is also the example for motional EMF. Here, if the resistance is going to be calculate the current value of I is equals to E divided by R. E is equals to dV into L divided by R. So this is equals to, this is for 18th question. The value of the magnetic field is 0.04 into velocity is 5 into L value is going to be 2 meter divided by resistance is going to be 3 ohm. This is going to becomes, we can write this one as 4 into 10 to the power minus 2 into 5 into 2 divided by 3. So it is going to becomes 4 by 3 into 5 into 2, it is going to becomes 10. So 10 to the power 1 minus 2 is going to becomes 4 by 3 into 10 to the power minus 1. So 4 by 3 means 0.75 into 10 to the power minus 1. That can be written as 75 into 10 to the power minus 3. As we are finding the equation for the value of current. So I is equal to 75 milliampere. Answer is 75 milliampere for 18. One minute. 4 by 3. Clear the correction. So it is going to becomes 4 by 3. 4 by 3 plus. So 4 by 3 is 1.33 into 10 to the power minus 1. This can be as 133 into 10 to the power. Decimal point is get shifted by 2 digits. So it is going to become 10 to the power minus 3 ampere. So that is equal to 133 milliampere. 10 to the power minus 3 stands for 133 milliampere. So the correct answer is the fourth one. That is for 18th question. Next, the current in a coil of inductance 0.2 Henry changes from 5 ampere to 2 ampere in 0.5 second. Magnitude of the average induced EMF. Again, you can calculate using this equation. That is E is equals to L into DI divided by dt. So the for 9th, the equation is E equals to L into di by dt equation use ಮಾಡಿ. The magnitude of the induced EMF, so that as they're going to given the material, the answer we're going to get is 1.2 volt. Answer we're going to get. Next, a physical quantity which is measured in the unit of Weber per ampere is self-inductance, mutual inductance, magnetic flux, both 1 and 2. Here, A and that is option first and second. Both the quantities are going to be measured in terms of Weber per ampere. Hence, the correct answer is fourth one, both 1 and as well as the 2. So next question, they are going to given the graph. This graph, observe the current flowing through the inductance coil of self-inductance 6 millihenry at different time instant as shown. The EMF induced between t equals to 20 second and 40 second. Well, 20 second and 40 second there. We're going to plot the graph. Here we're going to get the values of different values of I. So of the self-inductance L is equals to the EMF that is going to get induced. So E is equals to L into di divided by dt. Again, so L is equals to E into dt divided by di ಆಗುತ್ತೆ. So this is equals to wait 1 minute. We have to calculate the EMF itself. So EMF for that the equation is E is equals to L into di by dt. So direct I am going to take L value that going to given is 6 millihenry. So 6 into 10 to the power minus 3 into di value. Current value changes from 4 to 3 volt. You know, 0 is 0 to 4 ಕೊಟ್ಟಿದ್ದಾರೆ. So ಇಲ್ಲಿ ನಮಗೆ ನಿಂತಿರೋದು 4 ಮತ್ತೆ 3 ನಡುವೆ. So di value is 4 minus 3. 4 minus 3 ಅಂದ್ರೆ ಅಲ್ಲಿ 1 ಆಗುತ್ತೆ. Time between 40 and 20. 40 minus 20 that is equals to 20. So 6 by 20. So this is equals to 2 3s are divided by 2 10s are into 10 to the power minus 3. This is going to becomes 3 into 10 to the power minus 4. So 3 into 10 to the power minus 4 volt. This answer was not given in any options. Other that's why they're going to be given in the material as bonus. ಇದಕ್ಕೆ ಆನ್ಸರ್ ನಮಗೆ ಬೋನಸ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. But the correct answer is 3 into 10 to the power minus 4 volt. And next, a magnetic field of flux density 1 Weber per meter square acts normal to a 80 turns coils of 0.01 meter square area. If this coil is removed from the field in 0.2 second, the EMF induced in it is. So they are going to be asking about the magnetic flux value. Magnetic flux value is going to be given by NAB into cos theta ಅಥವಾ cos omega. So flux density of 1 of 80 turns, N value is 80 into area of cross section is 0.01 into B value is 1. NAB into cos theta, and here this cos theta value we have to take it as 1 because they are asking for maximum value. Flux density is going to be normal. So normal the theta value 0 degree ಆಗುತ್ತೆ. As a result, theta value is going to be 0 degree. They are going to be on cos 0 value is going to be 1. So this is the value of phi B, that is magnetic flux. This is equals to 80 into 0.01, that is equals to 0.8. And next they are asking, it is if it is going to get changes, then the value of the EMF is equals to E is equals to d phi by dt. If this coil is removed, coil remove ಮಾಡಿದಾಗ magnetic flux 0 ಆಗುತ್ತೆ. ಆವಾಗ d phi value 0.8 minus 0, time taken is 0.2 second. So numerator is 0.8, denominator is 0.2. So this is going to become 8 by 2. 8 by 2 is nothing but just 4 unit is volt. So 4 volt. 20 second is the correct answer. Next for 23rd question. So for 23rd question, you can use the equation as L is equals to N pi divided by I. They are going to given the value of N pi and as well as I. Then self inductance of the coil is L value ನೀವು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿದ್ರೆ ಕೊಟ್ಟಿರೋ ಹಾಗೆ ಆನ್ಸರ್ 1 Henry ಬರುತ್ತೆ. So the correct answer in this case is 1 Henry. Next in 24th question, this is going to be again according to Fleming right hand rule and as well as the motional EMF. So as the coil is going to be ring is moving vertically downward, direction of the current is horizontally towards your right side. So the direction of the induced current is going to be in a clockwise direction ಬರುತ್ತೆ. ನೀವು ಈಗ ಮನೆಯಲ್ಲೇ ಟ್ರೈ ಮಾಡಿ ನೋಡಿ ಇದನ್ನ if you going to apply the then right hand rule. And the last two questions. Just I'm going to explain. An induced current of 2 ampere flows through a coil of resistance. And in this equation, in this also, 25th, if we're going to use the equation E is equals to for 25th question, we're going to use the equation as E is equals to d phi by dt, which is equals to using Ohm's law I into R. And what is the change in the magnetic flux? That is d phi is equals to I into R into dt. In the equation substitute ಮಾಡಿ, then we're going to find the answer as 2 into 10 to the power minus 2. Further. So first one we're going to get. And this one, 26th. Here, the square loop of side length A is moving away from an infinitely long current carrying conductor at a constant speed. So it is moving away from this. As is that the magnetic flux is going to get decreases, and the correct graph is going to be represented by option 1. For this, for more information, if you're going to refer the graph of your Newton's law of cooling experiment in first PUC state, that is log of theta minus theta naught versus time, then the nature of the graph is going to becomes like this. Here also for this question, the magnetic field is going to be varies according to the logarithm value. So this is going to be completes this session. Thank you, one and all.